All right. The next kind of structure that we're going to look at are either frames or machines. And what these are they're basically structures that have multi-force members in them. Trusses, of course, had only 2 force members in them based on the assumptions we made about the trusses. Frames and machines, we're looking at multi-force. Okay, so, and basically the difference between a frame and a machine is basically what they do. A frame simply supports a load using multi-force members, and a machine does some sort of transmittal of forces, increases the force or changes the direction of the force or things of that nature. Now, really the best way to talk about these is to do a problem. So you probably want to move on to the example rather quickly. But the basic procedure on doing this is what we do is we break the frame or the machine up into its pieces. Okay, so, you can look at it as a whole, or you can look at it in its parts. And you'll more than likely need to figure out what's going on individually with each member. So you draw free body diagrams of each portion of the structure that you're looking at. Okay, so when doing that, remember to include any external forces. Now, when you start breaking this apart, there's internal loads, interactions between members that I have to take into account. Okay, and we'll show you how to do that in the example. So you want to include any external forces to the portion that you're looking at. Okay, if you've got any unknown forces, of course, you just assume their sense and the magnitude of them. Okay, but what you're going to want to remember is to keep with that assumption. If you make an assumption, stick with it. Okay, then when you move to another portion where, say, that same force shows up, okay, you apply Newton's third law and say, okay, it's the same force, so it's got the same magnitude. It's just in the opposite direction on this portion versus the other portion. Okay, so basically make an assumption and stick with it, using Newton's third law. Another helpful hint is recognize any 2 force members that might be in the body. Okay, because if you've got a 2 force member, then you know the direction, okay, of that force. Okay, so you can know basically one extra thing about the force. Okay, so you draw these free body diagrams of all the pieces. Okay, then you apply the equilibrium equation. Now each portion has 3 equilibrium equations, so each portion you can solve up to 3 unknowns. Okay, generally you may have to draw 2, 3, hopefully not 4 pieces to finally get enough equations to solve for the number of unknowns that you've created in breaking this apart. Okay, so you want to get enough equations to solve for your unknowns, and really with practice you'll start picking up on how to choose portions and equations to make your life a little bit easier. Okay, so again, the best way to do this is just dive in and start trying to do problems and get used to how you break things up and choose equations and things of that nature. Of course, when you solve things, if you get a negative answer, your assumption you made when drawing the free body diagram was incorrect. You just need to flip the direction of that arrow on that. Okay, but of course, if you do that on one portion, you have to do it on all the portions. So just make sure you keep track of what you've learned and what you know and things of that nature. Okay, and again, really, I would move on to the example. You're going to want to look at that because that's really it shows you how to actually deal with these frames and machines.